Hello everyone, my name is Anjali Chavan and I welcome you to the project on univariate time series forecasting using ARIMA model. In this project, we will analyze a single variable over a period of time and will forecast the same variable using time series model called ARIMA. Let's see the problem statement. In this project, we are trying to forecast electricity production for the next 12 months. So let's see how can you download the dataset. I have downloaded the dataset from Kaggle, that is electricity production.csv, and it has two columns. So let's see the data in the CSV file. So there are two columns, date and production, and the dates are starting from the year 1985 till the year 2018. So let's try to load this CSV data into our Google Collaboratory and we'll start with the project. So as a first step, I have imported the required libraries, NumPy, Pandas and Matplotlib. Then I have read the data using read CSV function of Pandas and I've also passed parse date as date column so that the read CSV function of that Pandas will analyze the date column as of type date and not of type object. Then I have set the date column as the index of our data frame. Then to check first few rows of the data, I have used head function. Head function will return top 5 rows of the data set. Then to check the last few rows of the data set, I have used tail function. Tail function will return bottom 5 rows of the data set. Then to see how many number of rows and columns that we have, I have used shape attribute on our data frame. So there are 397 rows and 1 column. So before starting with the forecasting, you should be aware about time series components, what does the stationarity means and how can you check the stationarity. So there are two main components, they are trend and seasonality. So trends are of two types, uptrend and downtrend. So if values are continuously increasing, it will be uptrend. If values are continuously decreasing, it will be downtrend. And what is the seasonality? Seasonality means if values are either increasing or decreasing within fixed period of time, that will be a seasonality. Then what is the stationarity? Stationarity means the mean is constant with respect to the time and variance is also constant with respect to the time. Now you have understood what are the time series components and what does the stationarity mean. But how can you check the stationarity of the given series? For that there are two ways. First one is by visual representation and the second one is by using ADF test. So ADF stands for augmented decay-Fuller test. So this is the statistical test which is used to test the stationarity of the series. So for that I have imported the ADFuller function from stats models library. Then I have defined a function to test the stationarity of the series. The function name is check stationarity which will take input as a series. Will pass this series to our ADFuller function. That function will return the test statistic, p-value, lags used, etc. But we'll focus on this p-value. So if that p-value is less than 0.05, it means that the series is stationary. But if the p-value is greater than 0.05, it means the series is not a stationary one. So let's try to use this visual representation and this check stationarity function on the electricity production series that we have. So let's try the visual representation first. So for that I have used this figure function from the Matplotlib library to plot the width and height of our chart. So I have set the width as 15 and height as 3. Then I have plot this production values that we have on this line chart. I have given title to the chart. On x-axis we have year, on y-axis we have electricity production which is present in megawatt hours. Okay. Now we'll also use the our custom function check stationarity to check the stationarity of our series. So here by observing this chart, so can you see is this series a stationary one? No. Why? Because the mean and variance both are not constant with respect to the time. If you can see the mean is increasing with respect to the time and the variance is also increasing with respect to the time. So this is not a stationary series. And we'll check what our check stationarity function has given us. It has also given that the series is not a stationary one because this p-value is greater than 0.05. Can you see any kind of trend over here? Yes, right? So there is upward trend over here. So what are the conclusions that we have got? there is a upward trend present, but the seasonality is not a present. And when your data is not having any kind of seasonality, then the best time series model is ARIMA model. Okay, now we have seen that this series is not a stationary one, but the main time series assumption is to make the series stationary. And how can we make this series stationary? So by using differencing technique. So what is the differencing technique is, we'll take the current production values that we have, current month production values, we'll subtract it from the previous month production values. That can be used with the help of this diff function. So we'll use this diff function on our data frame. We'll store it into the another data frame called as df1. We'll drop any kind of null values that are present, and let's try to see if the series is stationary or not with the both ways, that is with our visual representation also and with the check stationarity function also. So this series has now become stationary after using differencing technique. So here the p-value is very less, it is less than 0.05, and hence this series has become stationary. Now once you have found that the series is stationary, you have already found the value of d. So here we have taken the differencing for the first time. Hence the value for d will be 1. Now we have to find out the values of PDQ. So what this PDQ are and how they are related to ARIMA. So ARIMA stands for autoregressive integrated moving average, whereas the AR means autoregressive. Autoregressive means the values will be forecasted based on the previous values. MA means moving average, means values will be forecasted based on the past errors. And the D means number of times we have used the differencing technique to make the series stationary. So we have found the value for D as 1. So how can we found the value of P and Q? So there is a function called as AutoRima. So this AutoRima function will help us to find the values of P and Q. So we have to import this AutoArima function from PMD Arima library. Now I have passed that non-stationary series to this AutoArima function. Then I have given seasonal as false as our series is not at all stationary. Then I have given trace is equals to true, which means this AutoArima function will display the progress messages during the model fitting. Then I have given error action is equals to ignore, which means errors which are encountered during the model fitting will be ignored. Then I have written suppress warnings is equals to true, which means this function will suppress any kind of warnings that it will come across. And stepwise is equals to true. It means that it will use stepwise algorithm to search the best values of PD and Q. So I have given that production series that we have to our AutoArima function. Now let's check what summary that AutoArima function has provided us. So AutoArima function has provided us the best model. So this first part stands for non-seasonal order. This second part stands for seasonal order. As there is no seasonality present in our data, hence all these values are 0. And the non-seasonal order provided by the AutoArima function is 4, 1 and 2. So this 4 means the value for P. This 1 means the value of D. And this 2 means the value for Q. That is autoregressive term, integrated terms and the moving average terms. So our AutoArima function has given the best model for us. So let's see all the statistical value at once. So the Sarimax, it has used this Sarimax model as there is no seasonality. So we'll be using ARIMA model itself with the value for 4, 1 and 2. Now there are 397 observations that are present over here, and these are the respective their values of coefficients, standard errors and the p-values. So what does this means is that AR means autoregressive and L1 is the first lag. AR is autoregressive and L2 is the second lag. In this way, there are MA lags also, lag 1 and lag 2. MA means moving average. These are the coefficient values for that respective lags. This is the standard error and this is the value for Z. So this Z value is calculated by dividing this coefficient by the standard error. And this is the P value from which we determine the stationarity of the series. So these are the results that are a summary function that has provided us. Now let's try to see what best order that we have got. So with this order attribute, you can see the best order from the auto ARIMA function. So we have got the best order as 4, 1 and 2. So hence now what we'll do is whatever the output that we have got from our auto ARIMA function will pass the same values of PDQ to our ARIMA model. So for that you have to import this ARIMA function from stats models library. Then you have to pass that non-stationary series to our ARIMA model, and you have to pass the order that we have got from our auto ARIMA function. Now you have to train this ARIMA model, and let's try to see the summary. So this is the summary that is written by our ARIMA model. So these are the autoregressive first lag, autoregressive second lag, third lag and fourth lag, and these are the moving average first lag and the second lag, and these are all the values that I have already explained, right? So this is the summary that we have got from our ARIMA model. Now let's try to forecast. As we have trained our ARIMA model, it's time to predict the values. So I have given n forecast as a 12. So we have to predict the next 12 months electricity production, right? So here you can change over here also. So you have to predict for next 12 months or 24 months or 36 months. Okay, so here you can change it. Now, as I have stored that ARIMA model in our model fit variable, so we'll try to use the predict function and we'll try to make the predictions. So it will start from whatever the number of records that we have already present in our data plus the 12 records that we want to forecast. Now let's try to see the predicted values, and as you can see that these are the predicted values of the electricity production written by our ARIMA model. So ARIMA model has predicted these values for the next 12 months. Okay, so let's try to store this forecasted values into a data frame called as result df, and let's try to see the actual and the predicted electricity production values over the years. So in this plot you can see on x-axis we have year, on y-axis we have the electricity production which is present in the megawatt hours. So these blue line indicate these are the actual electricity productions that we have, and this red line indicate these are the predicted values of electricity productions. So in this way I have used ARIMA model. ARIMA model has forecasted the next 12 months values for electricity production in the megawatt hours. In this way you have to use this ARIMA model. So I hope you have liked this video. So if you have found this video useful, don't forget to like, share and subscribe to our channel for more such data science related content. Thank you.